Welcome back to Spank Ranch Garage. This evening we are working on a axle build for a buddy. This is a set of Dana 50 high pinion gears and a Dana 44 Detroit locker, some custom bearings, and all of it is going in this Dana 44 high pinion case. This is out of probably like a 79 or 78 Ford F-150. High pinion Dana 44, pretty desirable housing. Nice find on his part for getting this. What's interesting about this is the Dana 44 is an 8.5-inch ring gear, and we are going to be shoehorning a 9-inch ring gear into this, as well as going with a 5/38 gear ratio. And to do that, there is some custom machine work that needs to happen to fit some custom bearings in this by this guy, Jantz, out in, I guess he's in Washington, West Coast guy. So he's got all that figured out. We just need to do the machining and get this thing set up. So let's get started. A little information about rears before we get started here. So this is considered a high pinion rear. And what that means is you've got an axle center line here in which your carrier rotates on. The pinion rides on the north side of that. So this is pretty desirable up front, in my opinion. It gives you less crap to get hung up on, a little more ground clearance. It also gives you a better drive shaft angle. So if this was a comparable low pinion rear, this pinion would be down here. So you'd have a little steeper drive shaft angle. And then lastly, there are some strength advantages to a high pinion front axle. Specifically, what this means is you have a center line of your ring gear here, and then you've got your pinion. Your pinion really only fits in one place, and that is like so, right? That's where she drops in at. So you can see the pinion is on the high side of the center line. Now, the reason we are able to put Dana 50 gears in a Dana 44 is because when Dana Corporation designed the 50, which came out in the twin traction beam four-wheel drive Ford pickups, and then later in some of the F-250 Super Duties and the Ford Excursions, they kept this distance off of center line the same. So if this distance of center line was not identical, this swap would be literally impossible. These gears are cut and they will only mesh on a certain offset, essentially, of how high they are on the pinion. There is no negotiation there. Now, what we do have ability to play with is as this ring gets bigger, this pinion needs to be pulled back further into the housing. And with this custom bearing that Mr. Jantz makes, he machines the inside of this bearing. We're actually going to machine the case and push the inner pinion bearing further in. And then we're also going to move the carrier further away from the pinion to accommodate this 9-inch ring and pinion in a Dana 44 case. So let's get started. Thing's actually got some damage. It's got some chips on the ring gear. But you got to think, this thing, I mean, what, 1979, so talking almost 45 years old. I'm sure it's seen some things. Shims are all bent up behind the carrier bearing. I don't know, somebody might have been in here doing something. So you never know what you're gonna find opening up a junkyard rear, but at some point this bolt backed out and got caught and beat up the threads in the carrier, and that's okay. This guy bought all new parts to go inside this. We're just using the housing. But it's always worth taking a look. It's intriguing to see some of the history of this. Now, I want to explain why the high pinion design is stronger in a front axle application. If you look at what we have going on here, right? This is the carrier gear turning in the forward direction to propel the vehicle forward. So the gear is turning this way. In order for the pinion to be applying that force, the reactive force is going this way, meaning you're putting all of the compressive load of the pinion into the rear pinion bearing, or we'll say the front pinion bearing, essentially. But that's kind of the strongest way to do it. On a low pinion rear, the pinion gear is actually pulling on the ring gear instead of pushing on the ring gear. And that would allow basically any elongation within the pinion or additional load on the rear pinion bearing that's usually a little smaller. All that force is transmitted there. So on the high pinion, it's kind of just a little more of a rigid setup. I don't know percentage-wise how much stronger it would be, but people say that it is stronger. boy. Didn't expect to find that. So you really never know what you're getting into with these. I saw some weird stuff in the casting. I started cleaning it up, and that is welds and a crack. And likely what happened, so when that ring gear bolt came out of this thing, it actually blew through the bottom of the case, causing an oil leak. And it seems to be pretty thin there. I'm gonna flip it over, clean the outside, then I gotta call the customer and see if he's aware of this or if he wants to proceed. There was so much oil and grime built up on here, I didn't even know that this is fully JB welded along the bottom. And the JB weld is because the welding they did not stop the leak. So I just sent the customer pictures of this, and I don't think he's aware of this either. I want to see what he wants to do for a path forward, if he wants to find another housing or if he wants me to TIG weld this up. We actually chipped off the JB as we were talking on the phone, and you could see somebody's gone to town welding this, and honestly they didn't do a terrible job. I know what it's like to weld this type of material, and that's not a terrible job. Structurally, this axle is probably not too compromised, but that oil leak would be a doozy to stop. It's just very, very hard to stop an oil leak with welds on a rear. So he told me to hold off. He's gonna look for a new housing. And if he can't find one, then we'll reconvene and come up with a plan for this. He went on the hunt for another one of these 1978 or 79 high pinion 44 housings. And there's just nothing out there. Nothing within driving distance for a reasonable price. So he said, go ahead and try to fix it. So we will do our best with that. They do a terrible job. They got good penetration, and we can see some undercut here. They're getting in there, but there's just so much porosity in the weld, and yeah, I could see holes where oil's coming through. So just ain't gonna cut it. The old weld and all the casting roughness ground off. Hoping this shows up on camera here, but we've got a crack running this way. We've got another crack running this way here. And we've got another crack running across this way. So this whole section here took a blow. And to tell you how thin it was, when I was grinding on this, I got this section glowing red. You should not be able to turn a rear red in the center. A real casting should not turn red with grinding on it with a flap disc for a couple seconds, literally. So the idea is, I got 5/16 plate here, and I've cut various relief cuts in it. And what I'm doing is slowly manipulating this to match the curvature of the housing. And I'm pretty close, and I'm gonna actually have 2 or 3 plates all welded together to actually make this whole piece here. We're just gonna start with this 2.5 by 2.5 section. So I wanna tack this into position, and then I can start to hammer these edges to actually kind of follow the housing pretty nice, and then put a couple more welds in there. I'll be running 3/32, I think this is 309L stainless rod, and you can roast me in the comments for it, but I feel that stainless rod with the higher nickel content really works well bonding carbon steel to potentially cast steel or cast iron, whatever this is. Spark test is a little questionable. I don't know what this is made of, but who knows. But in the past, this has welded decent for me, so we're gonna give that a try. Got this plate all burned on and cleaned up. A lot of relief cuts. I pretty much had to relieve all the corners, the center here, and kind of just tack welded and beat this thing into submission until it mimicked the pattern of JANA 44 housing. So if you look at it from this side, it actually lines up with the lip here. So you used to be able to get hung up on rocks on this lip pretty easily, but now we have a smoother transition here. So if you come up on this plate, that'll kick you over the main lip. 2 passes all the way around, lots of 3/32 309L rod. And we'll see. I mean, no guarantees it's gonna hold oil. It's very hard to weld a casting to make it oil tight again on steel and iron. At least aluminum I seem to have no problem, but I don't have a lot of good luck with these kind of things holding, but there's epoxy for that. So I want to get this thing thrown up on the mill now, and we'll get into the actual intent of this video, which is fitting the Dana 50 gears into the Dana 44 housing. All right, it's the next night, and I had to do this all again for the third time. Reason being, we had interference with my boring head versus the edge of the bearing cap there. So I had to build this custom deep dive boring head to get this job done. Totally sucks, but it is what it is. I have a separate video on this if you're interested in that. It'll be a side job Saturday. Anyway, this is the ticket for holding this rear. This is what I found works. Jack stand on this side allows pivoting, you know, all around. And then 2 other points of contact. And these are a couple 1, 2, 3 blocks. Machinist jack. Same exact thing back here. Looks hokey. 1/2 inch all thread. This thing is not going anywhere. It's very rigid. Takes a lot of time to get this thing dialed in because, you know, you can't turn these machinist jacks once there's pressure on them or even just the weight of the rear on it. So it's like, I got to make an adjustment. I got to put a jack stand under here, hold the rear up, quarter turn, clamp it all back down over and over again until it's right. But now we are trammed in straight with this surface here. Now I can get centered up on this bore here. We will reach down with my new tool and we will bore this lip to receive this custom bearing. And that just needs to be a clearance hole, but we're going to make it as tight as possible. The actual recommended way to do it is to use like hole saws and stuff. And I'm not a massive fan of that. I'd rather get it super, super close. And that way, when this thing presses in, we have good support on the bearing. Because as you can see, about 60% of the bearing will be supported in the existing bore. And then this 40% of bearing here will be supported by, hopefully, the bore I'm about to make now. All right, this job is challenging me and my machining skills, but it is fun. So basically, also, the next challenge is finding center of that bore is very difficult because I've got obstacles everywhere. You've got a tab here. You've got a bearing cap here. Obviously, a standard edge finder is not going to reach. I tried edge finder in a chuck. The chuck is too big, hits all the obstacles. So what I ended up doing was setting my custom tool to exactly the diameter of the bore, and then bringing it down here and literally bumping the table back and forth. Perfect uniform drag all the way around the bore. So we are now on center with the bore. Zeroed up the DRO. I'm gonna lock the table, make sure nothing moves. And then we are ready to then set our tool back to the bore diameter we need to put the shoulder in, and then we can finally make our cut. So this is like 3 hours of setup just to make one cut, and that's just how it goes. It really sucks, but you want to do it right, you got to do it right. Oh man, that cut beautifully. Very cool. For reference, the work we're doing is almost 9 inches down the hole. So rigidity and tool stiffness is certainly a factor here, but we can make up for that with just taking gentle, light cuts. There's no hurry here. I'll take 50 cuts if that's what it takes, but we'll make it happen. Man, it's hard to measure down here because it's so tight. Put the tool in the way, but I can't afford to lose center. All right, we are currently 4 thousandths under size. So I got to think about that and be extremely careful with my next move. 27945 on the bearing. 27945 on the bore. 27940. Be just a smidge of a press fit, and that's what we want. The press fit is already handled on this bore here. This is just support, right? And the way this kit's designed, people actually punch this out with a hole saw and then put epoxy around it and press this bearing in. So what I want is, I want metal on metal contact here for the most amount of strength. and all the, most of the load is carried up here, but this back end of the bearing is important as well. So I figure boring this precisely and having this sit in a metal on metal facing here instead of, having a big gap that's filled with epoxy will just be better for the end result. So I'm gonna clean this up and we're gonna dry fit this bearing, see if it fits. If it does, we're in good shape. If not, what did I screw up? So I've shifted this over and pulled the tool out. So we've lost our perfect center. We did, lock it in the DRO, but that's only as good as it is. So I'm doing some careful deburring, inspection, and cleaning in here. And I'm gonna measure it one more time. And if we're good, we're gonna send that bearing home and that's it. I don't ever plan on taking it out again. So hopefully that goes in okay. Then we'll get on to our next step here, which is gonna require more boring on the mill to clear the pinion slinger. Here goes nothing. This is a real test of concentricity because we know we bored it to the size of the bearing, so any mismatch would be a concentricity issue. But I'm fairly confident I got that nailed. That's set. I'm gonna see if I have a seal driver that'll fit that, get some real good wax on it, but 76 millimeter seal driver fits perfect. I was able to ram that thing in. Nice press fit. And you can see that the bearing is substantially stepped below the face now. And that was the point of that stepped bearing, is that we've now moved the pinion down into the housing to allow space for larger diameter ring gear. So now the next step is to relieve this case to actually allow the pinion gear to fit here. So the Dana 50 pinion has this oil slinger that's going to fit on the pinion between the bearing and the shims, or actually between the pinion and the shims. But anyway, this is going to hit the housing. So now we need to start boring and stepping this out to basically move that housing down to the dimension of the new bearing. I'm going to pull the old pinion bearing off of the old pinion and put the new slinger on there. I'll make a setup bearing out of this, and that way we can do our test fitting with that. I'd rather keep the nice new bearings kind of out of harm's way until, it's time. So this is the Dana 44 slinger. Apparently the 50's got this bigger convex one, so we're gonna do the testing with that. See, that's what you want there. That way you get a nice concentric fit, right? There's no slop, but we eliminated the press fit of the bearing. That's what you want for setting these rears up. So you're gonna be taking this apart 50,000 times. Nobody wants to deal with that. So we're gonna set it up like this, and this is worst case scenario from a rubbing perspective here, because ultimately in practice there's gonna be a shim stack in here. So this thing's gonna come a little further away, but I'm gonna machine it so it clears at this stage. And that way, no matter how thin the shims are, we know we're not gonna have interference on the finished product. So this shield is pretty much hitting everywhere as expected. It's gonna use our boring bar that we built to basically start to bring this whole housing down until that thing spins freely. So I'm just gonna do it in steps, deepest in the center and then tapering outwards. Pretty much just eyeball it. This is a non-critical part of the job, just needs to be clearance, but you don't wanna take too much out and just go ahead and weaken the housing. So I will work my way up on this. All right, there it is. So she spins free without interference. I'll pull this out, show you what it looks like. Looks a little something like that. So some guys will take a grinder in here and grind at this and whatever. I cannot imagine that, especially up here where you really are getting into this radius of the casting and this gusset here. Really doing this on the mill was a pleasure. Now you can tell that surface finish is garbage. I mean, I'm sticking almost 4 inches out. Well, I'm cutting a 4-inch diameter with a little 3/8 boring bar, you know, on a homemade tool that's 9 inches out of the spindle. So it's gonna chatter, but that's part of knowing the work you're doing. This doesn't matter. This is strictly cosmetic. It's just clearance for that oil slinger. So I'm not gonna worry about it at all. So I got the carrier put back in with the regular Dana 44 gears. And I'm just gonna kind of mark where the gear is present. And that way when we put the bigger gear in, it's gonna hit, it's not gonna fit in the housing. I'm gonna need to know where to clearance. Just get an idea here. So right off the bat, the 50 gear doesn't even fit. Best case scenario, even if you center it up on the housing, she's not going in. So I'm gonna clearance it until we actually get the gear to drop in, and then I'll bolt it to the carrier, make sure it'll still drop in with that. All right, where are we hitting now? You don't have much on the bottom there. Up top, we clear the housing, we clear the flange, but down there, we hit the housing again. So, time to add a little more clearance there till she spins free. That's what's up. So I leave the preload off of it. I'll pull it all the way this way, make sure we clear. Looks good. Slide it this way. Looks even better. Wow, it's close down there too. Holy moly. Wow. Man, I tell you what, this is a tight stuff. Fitting this 9-inch ring and pinion where an 8.5 came out of. I mean, what's that? It's only a 1/4 inch in every direction, but goddamn. I wonder if the front cover even fits. Yeah, front cover clears. That's one thing. Not that he's ever going to use this one. This is just for storage. Well, that pretty much wraps this project up. We've got the Dana 50 gear set fitting in the Dana 44 high pinion housing. It's been a bit of a journey, you know, a lot of work fixturing this, a lot of work repairing that cracked housing. Luckily, ended up making that special tool, which really made this job possible. This job was not possible without this tool. I ended up using it for 3 separate operations here, and then a standard end mill for clearancing the flange here. But everything looks good. And that's pretty much my extent of this involvement with this project. Tomorrow I'm gonna bring this thing outside, pressure wash it, blow all the chips out, and then I'm gonna assemble it with setup bearings, loosely shim it together, just so it's all one complete package. Hand it back to the customer. He's gonna weld his braces on it and then finish setting up the rear and put it under a Jeep, a TJ. So pretty cool little project here. You know, this isn't one that I'm gonna make any money on. I got way too many hours into this for what I will charge for it. Really, it's what I learned. When I first started this job, I actually texted the guy and said, you know what, I can't do this. My boring bar doesn't reach the quill of the Bridgeport, you know, hits everything. I can't do this job. And then I was thinking, you know what? That sounds like a cop-out to me. So I was thinking in my head, you know what, if I built like an extended boring bar, maybe I could get down there and reach it, yada, yada, yada. And we worked through all of our challenges and ultimately got this thing done. I think it turned out amazing. So anyway, that's another project out of the way, another thing out of the garage, which means we got plenty more to do here at the Spank Ranch. So stay tuned for next time. Thanks for watching.